Now I'll be starting part 4, which has a difficulty level of 2. Okay, so it's a little bit more intensive than what we've done in part 1 to 3. So similar questions, but a little bit more intensive. So let's get started. Starting with question 26. It says change this decimal to a fraction. And as you can see, again, it's a recurring decimal. And the dots are only on top of the 3 and the 2, which means all three numbers, although one does not have a dot on top, it still means that all three are going to be recurring. Okay, so I'm going to let x be that one again. So x will be this decimal here, and as you can see, x is 0.0, 312, 312, 312, etc. So 312, all three numbers are repeated. Okay, now remember guys, when we did this question in part 1, we multiplied by some values of 10, haven't we? Now, what I'm going to do to start off with is multiply both sides by 10 first. Now, the reason for that is because I don't like to have the 0 in front of the 312. I think that's a little bit bothering. So to get rid of that 0, I simply multiply by 10. So this side becomes 10x, and this side will become 0.312, 312, 312. So the 0 in front of that 312 eliminates. So now it's nice and simple. The recurring numbers are just straight after the decimal point. Okay? Now if I do that, I need to consider another multiplication of 10. What I'm going to do is multiply this equation 1 by 1,000. So this side will become 10,000, and if I move this 3 spaces or places to the right, I will have 312.312. Okay, so that's what I get. And compare these two equations. Both equations have 312, 312, 312 straight after the decimal point. Okay, so if I subtract first equation from the second equation, I think that anything after the decimal point will eliminate, right? So I've done 10,000x. Whoops, this one's meant to be 10x, like over here. It's a little mistake there. So I have 10,000x equals to 312 or 312.312, etc. And then the second equation, or sorry, the first equation that I'm subtracting is going to be 10x. So make sure that's not x, that's 10x. Just remember that. Just a little mistake there. And then that's going to be 0.312. Okay, so I'll just put the decimal corresponding to each other so I know that all of these will be eliminated, they will cancel out. So I have this minus this is 9,990x, and this one is just 312 minus 0, which is just 312. So to get x, I just divide both sides by 9,990, so I have that over that, and I think you can simplify it and simplify the fraction, and you should get 52 on 1,665. Okay, so have a look there. I think you can divide by 3 or 4, I think. So do that. I think that was a pretty simple step for you guys. And as I said in the part 1, you'd like to put that into your calculator and see if it goes out, see if the number as a decimal comes out as 0.0312. If it does, that means you've got the right answer and you will get full marks for this question. Okay, so if you do have the time, I'd definitely suggest you just sub it back into your, or put it back into your calculator and check. Okay, that's question 26. 27. Okay, it wants us to simplify this expression, and as you can see, the denominators all have some surds inside. I don't like working with surds in the denominator, so the first thing I would do is rationalize both fractions individually. So this one I would multiply by the conjugate of 2 minus root 3, which is 2 plus root 3. So multiply by 2 plus root 3 on top and bottom. And this side I would multiply by the conjugate of 4 root 3 plus 7. So 4 root 3 minus 7 is the conjugate, which I'll multiply on top and bottom as well. Okay, so now simplify. 4 times 2 plus root 3 is 8 plus 4 root 3. And the denominator, as you can see, it's 2 minus root 3, 2 plus root 3. It's just going to be 2 squared minus root 3 squared. Okay, and this side 1 times that is just 4 root 3 minus 7, as it is. And this as well is 4 root 3 plus 7, 4 root 3 minus 7. So it will just be 4 root 3 squared minus 7 squared. So I've just separated this one out. So it's 4 squared and 3 root 3 squared. Okay? So let's simplify it. The denominator for this one, 2 squared is 4. Root 3 squared is 3. The roots and square cancel each other. And 4 squared is 16. Root 3 squared is 3. So 16 times 3, I get 48. Okay? And then 7 squared is 49. Now simplify further. Okay, well, before we do this, I'll show you what we get here. This one is negative 1. 4 minus, positive 1, isn't it? My mistake. 4 minus 3 is positive 1. And you should know that 48 minus 49 is negative 1. So this one is negative 1. So negative, positive will be a negative, wouldn't it? So 8 plus 4 root 3 on 1 is just 8 plus 4 root 3. And here, I'll just show you, that one becomes 4 root 3 minus 7 over negative 1. But we don't really need to put it over a 1. But we know that negative, positive makes negative. So I have negative 4 root 3. So this one equals 2 minus 7. So it's going to be negative 4 root 3 here and negative 7, which is positive 7. So that's how I get that. So again, add extra steps if you need to. Now gather your like terms, and as you can see, these will actually cancel out, won't they? So we're just left with 8 plus 7, which is 15. So 15 is your final answer. So eventually we don't need any certs on this question. Okay, so have a look at that one. This question, the only suggestion or a recommendation I would give you is to be extra careful, okay? Because it's sometimes a bit confusing, or it's easy to make some mistakes in this question. Okay, so that was question 27. Question 28, expand and simplify. Okay guys, let's just go ahead and expand it. So I'll have expansion of this first, and I'm going to keep it inside brackets because I have the negative in front. Whenever I say negative in front, I always like to use brackets and add an extra step, okay, just to avoid mistakes and confusions. So this one, x times 2x is 2x squared minus x times 3 is 3x minus 2 times 2x is minus 4x. So 3x minus 4x is negative x. And then negative 2 times positive 3 is negative 6. So that's how I expanded it. So some easy expansion there. And then go ahead and expand out the brackets with the negative. So I have 4x squared minus 2x squared. Minus is plus, so plus x. Minus is plus, so plus 6. Okay, so I've got rid of the brackets. And gather these two. These are like terms. So 4x squared minus 2x squared is 2x squared plus the x plus the 6. That's it. That's my simplest form of simplifying that one. Alright, so hopefully that was pretty simple. Just be careful again. Question 29, factorize this completely. Okay, now I think that first of all, whenever you do any type of factorization, you must find the common factor first. Okay, I think this one, the common factor is 2. So I'll take out the 2 first. So I'll have x to the power of 4 minus 16 left inside the brackets, because 32 divided by 2 is 16. Now guys, I think I can use my difference of 2 squares formula or rule. Okay, because I know that x to the power of 4, this I can show you how I change that. X to the power of 4 is x squared, and 16 is 4 squared. So I've got a square number minus a square number. So I'll go like this. I'll have 2 out the front, and then I'll have x squared plus 4 and x squared minus 4. Difference of 2 squares. Now guys, make sure that's not the end, because I can see that this one here is also a difference of 2 squares. This one is x squared minus 2 squared, isn't it? Because 4 is 2 squared. So I can go further. That will become x minus 2, x plus 2. So that's my final factorization. Okay, so remember you can go further make sure you stop until you can no longer factorize. Okay, so that's the answer to it, just using the difference of two squares rule. Okay, that's question 29. Question 30, factorize completely. Okay guys, I think first of all, I know that 3 is a common factor, so 81 divided by 3 is 27, 24 divided by 3 is 8. So I've got 27 plus 8x cubed left inside the brackets. Now guys, this time I can see a cubic. So let's see if we can apply our cubic factorization. You should know that, keep the 3 outside, 27 is 3 cubed, and then 8 is 2 cubed, and this one is x cubed. So I can change the 8x cubed to 2x, the whole thing cubed. So I have 3 cubed plus 2x cubed, so I can apply our rule. Remember, I'll write it for you again, but make sure you remember it. A plus b, a squared minus ab plus b squared rule. Okay, so I think we can apply that one to that, can't we? So, yep, I've put it in like that as well. That's just that same as that. So I'll apply the rule for this one. A is 3, b is 2x. So I have 3 plus 2x times a squared, so it's 3 squared, minus ab. A is 3, b is 2x, so it's going to be 3 times 2x. And then we're going to do b squared. B squared, which is 2x squared, which is 2 squared x squared. Okay, so all I did was apply this rule. So now let's simplify. 3 squared is 9, 3 times 2x is 6x, 2 squared is 4, so 4x squared. And that's it, we can't go any further than that, so that's our final answer of factorization. Okay, so as you can see, just this rule here, so it's crucial to memorize this one. So have a look at that one, guys. Just cubic factorization. Okay, that was question 30. Question 31, find a and b such that this fraction here becomes a, or is the same as a plus b root 3. Now what I've seen a lot of people do with this one is trying to just solve this equation. But guys, if you're trying to solve this equation together and trying to merge everything onto one side or whatever you tend to do, you can't really solve it straight away because this equation has 2 pronumerals. If you have 2 pronumerals, you can't really solve it straight away. So what I suggest you to do with this question is have a look at this side only. And again, as I said, I don't like having surds in the denominator, so first of all, I'm going to rationalize the denominator for this fraction, just like this. So the conjugate of 2 root 3 plus 1 is 2 root 3 minus 1, so multiply that on top and bottom, just like that. And then I'll have 33 times 2 root 3 minus 1, and the denominator, remember it's 2 root 3 plus 1 times 2 root 3 minus 1, so this times this is going to be 2 root 3 squared minus 1 squared. Okay, and 2 squared is 4, root 3 squared is 3, and 1 squared is 1. That's why we get 12 minus 1. Okay, 4 times 3 is 12. Okay, so that's simplified to 11 because 12 minus 1 is 11. And Alex 33 divided by 11, you can do that. It's just going to be 3, right? So even before I expand this, I can simplify it. So 33 divided by 11 is 3. Let's go ahead and expand that out. 3 times 2 root 3 is 6 root 3, and 3 times negative 1 is negative 3. Now guys, what you're going to do is compare this with this. Okay, that's what I've simplified from simplifying that one, and we know that that is the same as this, so this must be the same as this. Okay, you can see that if I switch these around, or switch around the order, I can have negative 3 plus 6 root 3. Okay, I just switch these two around. Doesn't matter if you do that, right? Now, can you see that these two are quite similar? See how this one has a square root of 3 and this one has a square root of 3? And this one has a b number in front of root 3. This is also a number in front of root 3. So therefore, guys, by comparing those two equations, I can see that a is going to be -3. So this is the same as this, okay, because that's the number in front. So a is -3 and b is simply the number in front of root 3. So b is simply going to be 6. Okay, so I found a and b just like that, just by rationalizing. So have a look. So the key to this question is trying to simplify this fraction here by rationalizing and then compare your solution with this part here. Okay, and you can get a and b very, very easily. Alright, so let's move on. Question 32. Okay, we're simplifying some quadratic fractions. So as you can see, we've got some quadratic expressions there. And we've also got some linear expressions. With these kind of questions, you must factorize first, no matter what. So I'm going to go ahead and factorize that individually. You can see that this one here, the common factor is x, so I take x out, and we have x plus 4 left inside the brackets. 3x plus 7, there's no common factors, so I can't factorize that any further. 5x plus 10, the common factor is 5, so I have x plus 2 left inside the brackets. And for x squared plus 6x plus 8, 8 is has the factors of 4 and 2. And we know that 4 plus 2 makes 6. So this one can be factorized as x plus 4, x plus 2. Okay, so I factorized everything. And because it's multiplying, all I need to do is see if I can cancel anything out. So I think I can cancel this and this and this and this. Okay, you can't multiply like things that are on side to side, but you can multiply things that are on top and bottom together if they're the same. Okay, so I can cancel that and that, that and that. Any more? No, I think we can't cancel any more. So now we simplify it. So 5 times x is what we have left on the top, on the numerator. So we have 5x on top and 3x plus 7 on the denominator. And that's the simplest form. 5x on 3x plus 7. We can't go any further than that. And that's it. So we've actually done this pretty easily, and all I've done is just factorize. So make sure you know your factorization very well. 33, sorry. I think this question is similar to what we did previously, 31 I think it was. Because again it says find the integers a and b, and they give you a little equation here. So again guys, what I would do, because there's two pronumerals, you can't solve it straight away. So I'm not going to work with both sides, I'm just going to work with this side, trying to expand and simplify it and see if I can compare it with this side. Okay, so let's go ahead. I'm going to expand that out. So 3 minus root 2 squared is 3 squared, which is 9, minus 2 times 3 times root 2. So 2 times 3 is 6, times root 2 is 6 root 2. And then plus the root 2 squared. So plus root 2 squared is 2. Okay, just some simple expansion there. I don't want to go through that in too much depth. Now simplify that further. 9 plus 2 is 11. So I have 11 minus 6 root 2. Now guys, again, compare this with this. Because I've expanded and simplified, I can't go any further. So now you compare this and this. Okay, what can you see? I think it's very, very similar. So I can say that the b is the coefficient of root 2, or the number in front of root 2. And just make sure these are the same. So very easily I can say that b is going to be the 6 in front of the root 2, and a is going to be 11, which is the number in the front. Okay, a is the number in front, so that's 11. So a is 11 and b is 6, and all I did to that was expand that side and compare it with this one. Okay, so how easy is that? Only required like 3 steps. Okay, so have a look at that one. And that concludes part 4.